Ratio of areas, section 11.7. We're going to investigate three relationships between areas of two triangles that have equal heights, equal bases, and that are similar. So before we fill in the notes up above, we're going to examine triangle ABC and triangle CBD. So if you notice triangle ABC and BCD, they both have a length of 5 and a length of 7 for their bases. And if you were to figure out what the area ratio of their areas would be, we know that both of these triangles share the same height. They share the same height. So we drop the height here, and the height is the same. We could call it H if that makes us happy. H in the yellow H. So now to find the area of triangle ABC, the formula is 1/2 base times height. The base is 5 and the height is H. And if we divide that by the area of triangle CBD, it's also the area is 1/2 7 times the height. So canceling things out, the 1/2s cancel, the H's cancel, and we're left with simply 5/7. And what is 5 and what is 7? Well, 5 is the base of this triangle, and 7 is the base of triangle CBD. And this only works if you have triangles with equal heights. So the ratio of the areas of two triangles with equal heights is simply the ratio of their bases. So that's the first relationship. How about if you have two triangles with equal bases? Here is a picture right here. Both of these triangles have base AB being the same. The triangle ABD has a height of 6. Triangle ABC has a height of 3. Again, the area is 1/2 base times height. The base of triangle ABC, we can call that, I don't know, B for base. The height of triangle ABC is 3. And we want to divide that by the area of ABD, which is 1/2 base times height. Canceling things out, you can see the 1/2 and the 1/2 cancel, the 3 and the 6, the B and the B cancels, and the 3 and the 6 remain the same. So 3 divided by 6, which by the way we can certainly simplify to 1/2. 1/2 or 3/6 are actually the ratio of these two triangles' heights. So the second relationship is the ratio of the areas for two triangles with equal bases is the ratio of their heights. The last relationship is if two triangles are similar, what is the ratio of their areas? Similar, this triangle ABC is similar to triangle DEF. So if we want the area of triangle ABC, we need to find the height. Well, the scale factor for this is 5:1, right? This is 5 times as big as this, so H has to be 5 times as big as 2. Therefore, H must be 10. So to find the area of triangle ABC, it's 1/2 base times height. And the area of triangle DEF is 1/2 base times height. And simplifying, the 1/2s cancel. We can do a little math simplifying here. The 10 and the 2 gives us a 5 left over and a 1, right? 4 goes into 20 5 times. So the area of triangle ABC, the ratio of the areas is 25:1. So can you examine this and see what the ratio of their areas are if two triangles are similar. Well, 25 and 1 and 5 and 1, this is the ratio of the squares of the scale factor. This is the square. So they are similar is ratio of the area of two triangles that are similar is the ratio of the square is the square of the scale factor. Okay, so going to the next page, we have two similar triangles where we're given that DE is 5 and AB is 2. So the area ratio is the square of the scale factor. So if it's 5 to 2, we just square 5 and we get, ABC is down here. We square 2 and we get 4. And then we square 5 and we get 25. So that's the answer for the first one. The perimeter they give you is 3 root 2, and the perimeter of this one is 11. This should be a B, ABC. So if you think about the perimeter of similar triangles, they are also follow the scale factor rule. So we would want to actually square this to get the ratio of their squares, of their areas, and square this. The denominator is easy. The square of 11 is 121. The numerator, 3 root 2, times another 3 root 2. Well, that would be 9 times 2 is 18. Okay, so this asks you to go backward. It gives you the area of the similar triangles ratio, and they want you to find their scale factor, so you would actually do the square root to get to here. That's a 7. Okay, so there's some word problems. There's a number of them. There's the rest of this page and 2 more. So let's just try to get through a few of these, and then you can finish these 2 pages for homework. Example 6. Notice that there are no similar triangles, but they give you these BDA and DBC. So they both have the same height. They both have the same height. So the ratio of their areas is the ratio of their bases. So BDA has a ratio is 7 and DBC has 3. So that's done. How about BCD, which is over here, and ACD, which is the whole triangle? They also have congruent heights. BCD has a base of 3. Triangle ACD has a base of the whole bottom here, and that's 10. Okay, turning the page. These are a little challenging, so just do this page, which is numbers 7, 8, and 9, and we'll leave the final page. Actually, I'm wrong, right? That is the final page. So I want you to try these on this page, example 7. And see you next class.